I'm Sonali Kelkar from City International School, and today we are going to do the revision of science, and this will be the third revision of science. So let's start today's session. First, we are going to do the revision of the chapter How do organisms reproduce, and then we will do the physics chapter, that is light reflection and reflection. Okay, so let's start with the first question. The question number one: two pink colored flowers on crossing resulted in one red, two pink, and one white flower progeny. Progeny means offspring. The nature of the cross will be. What should be the nature of the cross? If you cross over two pink flowers, okay, and after the crossing over of two pink flowers, the result we are getting is one red, two pink, and one white. Okay, so the nature of the cross, they have asked whether this cross is a double fertilization. Remember, in double fertilization we take two characteristic, and here if you see we have taken only one characteristic, that is the color of flower. Okay, then self pollination. Here if you go for self pollination, that means we are going to get the same color of flower even in the progeny. Cross fertilization, yes, so answer is cross fertilization. No, fertilization is not an correct option at all. Okay, so it should be a cross fertilization, children, because while doing the cross fertilization between the two flowers, we got a different colors flower, right? So the perfect answer is cross fertilization. uh, I'll, uh, I will recommend you to read the explanation by yourself. Question number two: a cross between a tall plant, that is TT, and a short plant, small tt, capital T, capital T. So capital T, it is a homozygous, homozygous tall plant. Okay, and small t, it is a homozygous recessive. This one is homozygous dominant, right? Dominant, and this is homozygous recessive. Okay, I'm writing the short form over here. Resulted in progeny that were all tall plants, because I will read it one more time: a cross between a tall plant, capital T, and the short plant, small t, resulted in progeny that were all tall plants, because why? You will get all the tall plants in the progeny. Let's draw a simple Punnett square over here, small t, right? So we are going to cross over, we are getting capital T, right? Here also capital T and capital T when you cross. Okay, this T with this T. When I'm crossing this T with this T, again I'm getting capital T, small t, and when I'm crossing these two, again I'm getting capital T and small t. Okay, why I am getting all the tall plants in F1 generation? We are getting all the tall plants in F1 generation. First of all, if you see, okay, uh, if you see over here, they are hybrid and the tall is the dominant trait. So that is why in F1 generation you got tall, all the plants tall. So the first answer is the right answer. The tallness is the dominant trait. Okay, that is why we got all the plants which are tall. Next question: if a round green seeded pea, see the two characters we have taken. First one is round and other one is green. Seeded pea plant, R, capital R, and green, for green we have taken a small y. Okay, so round is a dominant character, and y, which is representing here green color of seed, okay, it is a recessive character, as the letters of small, as the letters are small y, right? So is crossed with the wrinkle yellow seed. Wrinkle yellow seed, so wrinkle over here is a recessive character, denoted by uh, small r, right? This is recessive character, and yellow is a dominant character. Just remember which is a dominant character, which is a recessive character. Here the seed production in F1 generation. So what should be the seed produced in F1 generations? So let's make first gametes and then we are going to cross the gametes, right? So gametes will be having a round and yellow, or we can say and round and capital yellow. The next gamete will be having a round, a wrinkle and green, and wrinkle and green. Okay, so we have taken the gametes of the pure round and yellow and pure wrinkle and green, right? So whenever I cross over, if you see, even if I make a one cross, the result for the rest of the three will be same. Okay, let me cross this one. I'm getting capital R, capital Y, small y, isn't it? So the seed, okay, or the progeny will be round and yellow always. Even if you cross this, okay, you cross this one with this, or you cross this one with this, you will get capital R, capital Y, small y. So the resultant seed will be round and yellow. Okay, so the answer first is the correct answer. Question number 4. In human males, all the chromosomes are paired perfectly except one. Okay, in males, remember, when you read the question, you have to read it very carefully. This or these unpaired chromosome is or are. They are large chromosome, they are small chromosomes, they are Y chromosome, they are X chromosome. So answer is always a Y chromosome. Okay, that is why they are. That is why, due to the Y chromosome, the male has all the characteristic of male. Okay, answer C is the right answer. Third, it is the Y chromosome, and fourth, the X chromosome. Yes, X and Y chromosomes, when we cross over, we are getting a male. So the C one is the right answer. I'll read it one more time. In human males, all the chromosomes are paired perfectly except one. This or these unpaired chromosome is or are. Okay, they are Y chromosomes, which can pair with Y chromosome can pair with X, or X chromosome can pair with Y. Okay, so we are getting the answer is C, where the right answer are X chromosome, Y chromosome and X chromosome. Here the explanation: human males are hemizygous for X and Y chromosome. Okay. A zygote which has an X chromosome inherit from the father will develop into a, because see, from female we are getting only X and X, from male we are getting X and Y, right? This is male and this is the gamete of female. Okay, these are the gamete of male and these are the gamete of female, right? If I cross over from male, I have taken X as given in the question, X chromosomes, right? And female, definitely it will going to pair with the X, because female has both the same chromosome, that is both the chromosomes are X chromosome, X chromosome. So definitely the girl, the child will be baby girl. Okay, so human follows XX and XY mechanism for sex determination. So this is the explanation of this question. Question number 6. In peas, a pure tall plant TT is crossed with the short plant small t. The ratio of the pure tall plant to the short plants, right? So I here let us draw a table here. See, the question they have asked the ratio of the pure tall plant to short plants, right? So small t and small t. So it will be capital T, small t. Here it will be capital T, small t. Again cross over this, you will get capital T, small t, and you will get over here capital T, small t, right? So we are getting the ratio over here, okay, this is my F1 generation. And what about the F2 generation? F2 generation, I'll take the two gametes and cross over. My two gametes are capital T, small t, and here is capital T and small t, right? So if I cross over here, I'm getting capital T, which is a pure tall plant as mentioned here, and capital T, small t. This is not a pure one, this is a hybrid one. Capital T, small t, and small t, small t. So if I go as per the question, they have asked the ratio between the pure tall plant to short plant. Okay, so between pure tall plant, there is pure tall plant 1 and the short plant is also 1. So ratio will be 1:1. Okay, you have to read the question very carefully. Now over here in this question, they have written the phenotype 3:1. Here I want you to do the correction. If they ask what is the ratio between tall plants and short plants, then you can write 3:1, then this answer is correct. Okay, otherwise this answer is not correct. The answer is 1:1, which is the correct option. Okay, let's see the next question. This from here onwards, I have taken a questions from the chapter Light, Reflection and Refraction, that is chapter 10. Here goes the question. Which of the following can make a parallel beam of light when light from the point source is incident on it? Okay, so when a light from the point source incident on it, that means after a reflection or after refraction, what happens? So concave mirror as well as convex lens, this is the right answer. Let's see how this is happening over here. If I put a object, if I'm going to keep an object at focus, remember, if I keep an object at focus in case of concave mirror, this one is my concave mirror, right? Mirror, and if I keep the object at focus, one light will go to the mirror, reflected back and passes through the focus, right? A light which is parallel to the axis after reflection passes through the focus. This is the law, right? And then what happened to the next light? Now the next ray is going from the point object. After reflection it passes through the center of curvature. Okay, the other line will passing through the center of curvature, and if I see, both the lines are parallel. Okay, so after the reflection from the point object, the lines are parallel in case of concave mirror. Same thing will definitely happen in convex lens, because we know that the concave mirror and convex lenses, they form similar type of images. So if I keep an object at focus in case of convex, this is a convex lens, right? So when I keep it, what is happening? One ray will go from the optical, okay, from the optical center, okay, and the other ray is happening. What is happening? It is parallel to the principal axis. Okay, after refraction, it will go through the focus, and here also I can see that both the beams are parallel to each other. Number 8, children. A 10 millimeter long oil pin is placed vertically in front of concave mirror. Okay, so what you have to remember over here, you have to keep in mind that it is a concave mirror. Fine, you should know in concave mirror where the images are formed. Okay, you should know the ray diagram related with concave mirror. Why I have drawn this? This is a Cartesian. Okay, here all the positive sign are going to come, here all the negative signs are going to come. Okay, this is my right hand side, this is my left hand side, right? On top, okay, if I take the top, on top all positive comes, and at bottom all negative comes. Fine. So let's see what have they given. They have given that 10 millimeter long oil pin is placed vertically in front of concave mirror. So 10 millimeter is the height of an object, which is denoted by small letter h. Okay, and the height of an image is 5 millimeter long, which is denoted by h dash. Of the oil pin is formed at 10 centimeter in front of the mirror. So this is a image distance in front of the mirror, so it will be a -1. Okay, image distance. So if you see over here, image distance, that is v. Image distance is denoted by letter v, and object distance is denoted by letter u. U come first, object, definitely there has to be object first, and then only the image is formed. So this you have to remember. So u come first, object come first, image come later, v came later, v also comes later. So okay, we have to find over here object distance u, and we have to find the focal length of the mirror is. So we have to also find the focal length, but before focal length we are supposed to find out the object distance, that is u. Okay, so which formula we are going to use over here? We know that m is equals to height of an image divided by height of an object, which is also is equals to minus v, that is the image distance, divided by u, that is the object distance. Okay, so using this formula we will find out the object distance, that is u. Okay, so let's substitute the values directly. H dash, what is over here h dash, that is what is the height of an image. It is given in 5 millimeters, so definitely you need to convert into centimeter. 10 millimeter convert into centimeter. So I'll write 0.5 divided by 1 is equals to minus 30. Children, why I have taken this as object distance? Because object is placed in front of the mirror. Okay, now according to Cartesians, you must have done the graph. So on the left hand side, all negative value comes. So that is why if this is an object, okay, so distance between the mirror and the object I will consider as minus 30 centimeter. Okay, so minus 30 I have taken, and u I am supposed to find out. So if I solve this, I'll be getting minus 30 divided by 0.5. Okay, minus 30, when you multiply with 1, it will be minus 30 only. So okay, now I have to remove this point decimal, so I have to put a 0 over here. So if I divide minus 300 by 5, I'll be getting minus 60, right? Minus 60 in centimeter. I have already converted all the millimeters into centimeter, right? So I have got over here the object distance, that is u. Now because I have to find out the focal length, so I'll be using the another formula, that is the mirror formula, because it is a mirror. So 1 upon f, remember 1 upon f is equals to 1 upon v plus 1 upon u. This is my mirror formula. So with the help of this, I'm going to find out the f. So 1 upon f is equals to 1 upon v was 1 upon v 1 upon v was 1 upon minus 30, and 1 upon u, we got the value of u, that was 1 upon minus 60. And you have to find out the LCM of 30, 60. Definitely it will be a 60, right? And what we are going to get here, minus 2 and then minus 1. So it is becoming minus 3 upon 60. 1 upon f is equals to 1 upon f is equals to minus 3 upon 60. If I have to find out just f, what I have to do? I have to reverse it. Okay, so 60 will go to the numerator, minus 3 will go to the denominator. If I cut it, I am getting minus 20 centimeter. Okay, so minus sign with the 20 shows that even the object is placed in front of the mirror. Okay, so this is how we have to find out this, find out the answer of this numerical. Let's do the next question, children. Okay. A figure shows a ray of light as it travels from medium A to medium B. Refractive index of medium B relative to medium A is. Okay. So if you see the medium A, and this is medium A, this is medium B. Fine. And the refractive, we have to find out the refractive index of medium B related to medium A. So we are going to use the formula. Refractive index denoted by the letter N, or you can say nu B with respect to A. So here what we can do, because they have given the angles, that is they have given the angle of incidence and angle of refraction, so we can use the Snell's formula. Okay, that is also one of the method to find out the refractive index. So that says sine I upon sine R. Okay. Now what is sine I? Sine I is the angle of incidence. If you see the ray very carefully, the angle of incidence. So this is angle between the normal and the angle of incidence. Okay. So this is my normal and this is my incident ray. So the angle over here is 60. So I have to take sine 60, right? And the angle of refraction, yes, it is between the normal and the refracted ray, that is 45. So I have to take over here sine 45 degree. Okay, let me just clear this thing. Sine 60 divided by sine 45 degree, right? So what is sine 60? The value of sine 60 is root 3 upon 2. Okay, root 3 upon 2. And what is sine 45? Sine 45 is 1 upon root 2. So we need to solve this. So what we have to do, root 3 upon root 2 multiply by 1 upon root 2, then denominator also 1 upon root 2. You have to multiply 1 upon root 2 with 1 upon root 2. Okay, so when you multiply this, what are we getting? Okay, we are getting root 3 and we are getting 2 root 2, right? Here we are getting 1 upon 2 because root 2 into root 2 is 2, right? So I'll solve here. Minus root 3, 2 root 2. It is divided by 1 upon 2, so it will become 2 upon 1. This 2 and this 2 will cut and we are getting root 3 upon root 2. So this is my final answer, root 3 upon root 2. Okay. So just make a change over here, children. This should be root 3 upon root 2. So it should be root 3 upon root 2. This is the right answer. Or else what you can do is you can make this as root 3 upon root 2. Okay. So this will be the right answer in this case. Root 3 upon root 2. Let's do the next question. Question number 10. A light ray enters from medium A to medium B as shown in the figure. The refractive index of medium B relative to A will be. So we have to find out the refractive index of medium B relative to medium A. So I will write medium B relative to medium A, and I have to see. Now if I see this diagram carefully and if I extend this ray, this is the incident ray, children. It is moving from, this light ray is moving from medium A to medium B. Now if I extend this ray, if I see, it has to go in this way, but I can see there is a bend in the ray. Okay, so there is a bend in the ray, that means definitely there will be a change in the speed. If the speed of the light decreases, it bends towards the normal. This is the normal. Okay, so in which medium does the speed of the light decreases? In the denser medium. Okay, in the denser, when light moves from a rarer to the denser medium, it bends towards the normal. This was the rule of refraction. So definitely this shows that my medium A is a rarer medium and my medium B is a denser medium, right? And because of that there is a change in the velocity. The velocity has decreased and the light is bending towards the normal. Okay, so in this case definitely the refractive index of medium B relative to A will be greater than the unity, because the velocity of light in medium A is greater than the velocity of light in medium B. Okay. Next question. Beam of light are incident through holes A and B and emerges out of box through the holes C and D respectively as shown in the figure. Which of the following could be inside the box? If you see the beam of the light A and beam of the light C, you will see that these incident rays are parallel and the emergent rays are also parallel, right? Here also in B and D the same case. So we can say that the emergent light rays are parallel to the direction of the incident light ray. So what it should be? It should be a rectangular glass slab. Question number 12. Which of the following statement is true? Okay. Here the convex lens has 4 diopter power having a focal length of 0.25 meter. Okay, now convex lens 4 diopter power having a focal length of minus 0.25 meter. Here I want to tell you one thing, children. Convex lens, if we know the convex lens, we know that the primary focus of the convex lens is on the right hand side. Okay, so according to Cartesian, according to your rules in graph, on my right hand side all positive values come, right? And here in the second option they have given negative. In convex lens you will never find power in negative, so this option is out of the point. The concave lens has 4 diopter having a focal length of minus 25. Concave lens has a negative focal length, so this is also not an correct option. Concave lens has diopter power having a focal length of minus 25 meter. So let's see what is the answer for this question. Here convex lens have 4 diopter power having a focal length 0.25 meter. This is the right option. How to find out? Power is equals to 1 upon f. Okay, now what is 1 upon f is they have given 0.25, so 0.25 divide 1 by 0.25, it will come. I have to remove this point by 20, that is it will become 100 upon 25, so it will come 4 diopter. So this is the right answer. The first one is the right answer for this question. Question number 13. Magnification produced by a rear view mirror fitted in vehicle is less than 1. Rear view mirror magnification. In rear view mirror, what mirror we use? Convex mirror. Okay. Now what should be the size of the object in convex mirror? Why do I put first convex mirror? Because I have to cover a large area and I can see the vehicles which are coming from my backside, and the vehicles, definitely the size of the vehicle will be the less than the size of the image. So what should be the right answer? The first one is the right answer. Here let me read the explanation. Convex mirror is used as a rear view mirror in vehicles. It forms virtual, erect and diminished images of the object. This is the purpose of my rear view mirror. Okay, I want to see a large view of the a large view, as well as I want to see all the vehicles erect and diminish. So the magnification is the ratio of the height of the image. We know that what is magnification? It is ratio of the height of the image divided by height of an object. Okay, m is equals to h dash upon h, right? Okay, so hence magnification produced by the rear view mirror fitted in vehicle is less than 1. Okay, so definitely the height of the image is less than the height of an object, so the magnification will always be less than 1. Next question, rays from the sun converge at a point 15 centimeter in front of the concave mirror. Okay, so if it is a concave mirror, so at some rays are coming and they are converging at a point. Okay, now this point definitely will be a focal length or focus. That is 15 centimeter is the focal length and the point is focus. Where should be an object be placed so that the size of the image is equals to the size of an object? Okay, we should know that size of the image equals to size of an object. In case of concave mirror, it is center of curvature. Okay, so the and what is center of curvature? Center of curvature is always double of the focus. So what should be the length of the center of curvature from the pole? It should be 30 centimeter, which is double of my focal length, right? So 30 centimeter in front of the mirror is the right answer for this. Next question, which of the following ray diagram is correct for the ray of light incident on a concave mirror as shown in the figure? If we see the concave mirror ray of the light, I have taken this question because it will remind you about the laws, okay, while making a ray diagram in case of mirror. Okay, if a line is parallel to the principal axis, this is my principal axis, right? And this is a ray parallel to the principal axis. A ray parallel to the principal axis, after reflection it goes back through focus, right? So let's see in which case it is going back through focus. Yeah, this is the figure D is the right answer, right? A ray of light going parallel to the principal axis towards the mirror after reflection will pass through the focus. So figure D is the correct answer. Coming to the next question, which of the following ray diagram is correct for the ray of light incident on the lens shown in the figure? So we know that ray of light, if passes through the focus, after refraction, it is parallel to the principal axis. So which diagram is showing? Okay, this A is showing the correct answer. So A is the correct answer for this question, right? Coming to the next question. Height of 5 centimeter. An object of height 5 centimeter is placed perpendicular to the principal axis of concave lens of focal length 10 centimeter. If the distance of the object from the optical center is 20 centimeter, determine its position, nature and size of the image form using the lens formula. Before this question, we have done a question where we have used mirror formula. So in mirror formula, what is the mirror formula? 1 upon f is equals to 1 upon v plus 1 upon u. Okay, so I would advise you to learn only one formula. You can learn mirror formula, and the lens formula is just opposite to that. In a sense, the lens formula is 1 upon f is equals to 1 upon v minus 1 upon u, right? Now let's find out what is given over here. Height of an object is given 5 centimeter, right? It is given in centimeters, so we don't have to convert. Then height of the concave lens is okay. Focal length of the concave lens is minus 10 centimeter because it is a concave lens, children. Concave lens have focus at the front. If I go according to Cartesian, then on the left hand side is forming my focus, okay, and 2f is on my left hand side. So my principal focus is falling on the left hand side. So I have to take focus minus 10 centimeter. Okay, and what is given? If the distance of the object from the optical center, so object distance is given, that is u, and object in case of a concave lens, the object is always placed in front of the mirror. So in front of the mirror, even in that case, I have to take the number as a negative, that is minus 20 centimeter. Now let's substitute the value in the formula. I have to find out the distance of the image from the lens. So 1 upon v is equal to 1 upon f is equal to 1 upon u. So if I substitute the value 1 upon minus 10 plus 1 upon minus 20, okay, so I'll be getting LCM of 10 and 20 is 20. So when I solve this, I will get minus 3 upon 20. What is v? V will be minus 20 upon 3, that is minus 20 upon 3 centimeter. So we were not going to convert it into decimal. We'll stop here, okay, and we will find out the other thing. We have to determine the position, nature and the size of the image. Okay, now hence the image is situated at the distance minus 20 upon 3 centimeter from the lens on the same side. Minus means definitely that is on the front side, same side of the object, so the image is virtual. On the same side, if it is falling, the image is virtual. Now let's see the magnification. Okay, so what is the formula of magnification? M is equals to h dash upon h, that is height of an image, divided by height of an object, which is equals to v upon u. In case of lens, magnification is M is equals to h dash upon h is equals to v upon u. In case of a mirror, we have taken minus v upon u. Okay, in case of lens, we are not going to take that. Okay, to find out the height of an image, what we have to do? Okay, now we'll substitute the value height. Okay, height of an image over here was we have to find out the height of an image, that is h dash. Height of an object was 5. My distance of image from the lens was minus 20 upon 3. So I'll take minus 20 upon 3, and distance, image distance done, object distance is minus 20. So I'll take minus 20, right? So if I solve this, I will get h dash upon 5 is equals to minus 20 divided by minus 60. This minus will go off. Okay, my h dash is equals to 20 multiplied by 5 divided by 60. This h is going to multiply by 60, right? So whenever variable multiply with the number, put the variable on one side and the number will go to the denominator. So this and this will cut 2, 3, and you have to cut 5 by 3. So I'll get 3, 1 are 3, 1.666. So I will consider it as a 1.67 centimeter. Okay. So this clearly shows that the image is virtual, it is erect. Magnification is positive, right? So whenever you get the positive magnification, that means the image is virtual, and image is erect. Because it is virtual, it has to be erect, and it is more than the size of the object. Okay, so this is how we have to do this sum. Thank you so much, children. Practice today's topic.